Activate and open up the Webpack. Close the tip of the day. Close the residual project if there is any. Create new project. I will put it in some scratch folder that I call it X. Let me remove that. And then provide the project, say Johnson 4. Click Next. Override, whatever. Select the proper Spartan 3 device. XC3S200 is the one on the board. Footprint 256 and the speed grade -4 or 5. Synthesis tool XST. Click Next. New project. Select schematic. Provide a name. Let's call it also Johnson 4. Click Finish. Next. Next. Finish. Then a so-called schematic sheet will appear on the right hand side. Let's move this in to see that. And on the leftmost navigator area, you got category. Let us select the counter. Okay. Open up the Johnson counter schematic. Pick the counter, bit counter, cascadable 16-bit. Double click, drop it here. Pick the next one, the 8-bit. Uh, 8-bit. Over here. Pick the 2-bit. So that will be a total of 26 bit. Let's magnify this. So we plan to divide our system clock of 50 megahertz by 2 raised to the 26. That will give us an approximately 0.75 hertz, slow enough for us to see the progress of the bit in the Johnson counter. Now, to find out what kind of how to use this, you double click the icon, click the system info, then a PDF file description will appear. Here, it's a macro for Spartan 3. And basically, the write-up say they are cascadable. And to do that, the CEO, the clock-enabled output, should be connected to the clock-enabled input of the next stage. And this is the truth table. When the clear line is high, the output goes low. The timer complete is low, regardless of the clock. But when the clock enable is high and the clear is low, then each time the clock line C rises, it will increment the output count. The TC will go high when all the bit in the counter is high. And this description is good for all those three counter. So we have to cascade it. We got to wire it. TC out to TC. TC out to TC. And we will use this line to clock our Johnson counter clock line. That's all we need. Now, we will connect, of course, the port to this end for the so-called clock enable. So later on, you may have to change that name to for a more suitable symbol like CE. And likewise for the clock. Oh, well, the clock, in our case, our clock is in our design, we call that CLK50. That's what we call it. And we will connect here is and call it reset. So we will have to connect a port there that we will name it as reset. And that will be connected to the next, including the Johnson counter. This line will go to the clock input line of the Johnson counter. Okay, this one we will connect to slide switch 0 of our board. So the next thing to do is to connect a handful of data flip-flops. That is, in flip-flop they call it F. If there is a clear input, then that is FDC. The FDC underscore is a negative H data flip-flop, which we will not use. So we will position this so that this one is the D output, this is the C, because the B is feeding the A. And then the output of A is routed back to here, and we connect here an inverter. This clock line is coming from the TC out of the clock division chain, and then we will connect to this clear line, the reset, like we did here. So that's all it is. It takes time to make this really work, so I will not continue that. But the next thing we have to do, what I'll do is close this and go over to our working project that I did earlier, which is, I put it in a folder. I call it Johnson, inside that Johnson 4.